Welcome to the Deep Dive. We're the place you come to, really cut through the noise and get the essentials on big tech shifts. Think of it as your shortcut to understanding what's next. Today, we're strapping in for a look at the architecture of the new internet. People are calling it Web4. And specifically, we want to unpack how its design really promises to shift power, away from those huge centralized tech giants that pretty much run our digital lives right now.
Exactly. Our mission today is pretty focused. We're trying to move past just the buzzwords like decentralization and actually look at the blueprints, the technical details. We're digging into that core tension, that big shift from Web 2, which is all about massive centralized control, harvesting data towards this Web 4 idea, which puts the focus squarely on decentralized autonomy. And importantly, particularly for the community networks that people actually use day to day.
Right. And we've got sources here that detail the technological heart of it all, the stuff that makes this, feasible. We're talking about these highly specialized micro-language models, MLMs they call them, and how they combine with this infrastructure, social networks as a service, or SNA. Is that right?
SNAs, yes. And how these elements allow networks to actually thrive outside the usual Silicon Valley data silo model.
Yeah.
This isn't just some, abstract philosophy. It's a detailed technical plan for how communities can achieve real data sovereignty, often right down at the local level.
Okay, so it's grounded in tech.
And that tech is grounded in a specific philosophy. Trustless systems. It's a really core principle here, guiding everything, the architecture, the code, all of it. Now, trustless in this context doesn't mean you can't trust anyone. It means the system itself is designed to minimize the need for you to place blind trust in any third party.
Like a platform owner or a developer.
Precisely. Whether that's a server admin, a big corporation, even the network developer. The architecture uses things like cryptographic proofs, auditable open source code. These things enforce the rules. They grant verifiable autonomy. And crucially, any AI built into these systems, it's designed only to serve the community's utility and health. It's completely separated from those profit-driven algorithms we see in Web 2 trying to maximize ad engagement.
Okay, let's unpack that shift then. Let's look at the fundamentals. Because when we talk about the difference between, the internet we use now, Web 2, and this Web 4 vision from folks like Linksbreed and Web 4 AI, we're talking about more than just features, right? It's the whole operating ideology that's different. You mentioned 4 critical distinctions.
Yeah, if you really strip it down, the underlying mechanics of Web 2 and Web 4 are, they're practically opposites. First, just look at the operating model. Web 2 is all about centralized platforms, massive data silos, all the power, all the control. It rests with one company.
Right, the Facebooks, the Googles.
Yeah, exactly. Web 4 just flips that completely. It mandates decentralized, federated, community-operated networks.
Federation. That word seems key. It's not just one big decentralized thing like a single blockchain for everything. It means lots of independent networks that can still talk to each other.
That's it, precisely. Federation is critical. Think of Web 2 like one enormous city owned by a single mayor who makes all the rules. If you break a rule, or even if the mayor just decides to change the rules tomorrow, you have no choice but to follow.
Okay.
A federated network, on the other hand, it's more like a cluster of independent towns. Each town sets its own rules, its own governance, manages its own infrastructure. But crucially, they all agree on a standard way to communicate, like an open language or protocol. So if one town becomes, say, toxic, or its policies change drastically in a way users don't like,
you can just move to another town.
You can move, potentially taking your connections or data with you, depending on the protocols, and still interact with people in the old town if the protocols allow. It spreads the risk. It gets rid of that single point of failure control.
Okay, that makes sense. And spreading the risk. That leads us straight to the big one. Data control. Web 2 is built for data harvesting. We know this. They grab every click, every connection, even your drafts sometimes. Web 4 promises data sovereignty back to users and communities. And you're saying this is enforced by something called on-premise security.
Yes, and data sovereignty in Web 4 isn't just a policy statement. It's baked into the technology.
Yeah.
It means the community administrator, the person running that specific instance or town, has direct custodial control over the database, not the platform developer like Linksbreed or Web4 AI. That technical control is fundamental because if the raw user data never has to be sent to some external server for analysis or processing.
It can't be easily scooped up and monetized by third parties.
Exactly. It can't be weaponized for external profit motives. Which ties into the next point. The intelligence strategy. Web 2 relies on these huge cloud-based large language models, LLMs. They're general purpose, very expensive to run, and they inherently create privacy risks because your data has to be sent off somewhere else for the AI to work on it.
Right.
Web4 takes a radically different approach. It champions specialized, on-device microlanguage models, MLMs. These are designed to be incredibly fast, run locally on your machine or within the community's own server, and super efficient. They handle specific tasks without needing that network lag or cloud access. This is really the key to making sophisticated AI affordable and private enough for just a single community to actually deploy and manage.
Okay, local processing, local data, local control. Which brings us to the money, monetization. If Web2 lives on ads and selling data insights, meaning algorithms are always tweaking what you see to make more money, how does a Web4 network keep the lights on without that huge ad revenue stream?
It shifts the model entirely. Web4 structures its finances primarily around small, community-defined membership fees. Now, this sounds simple, but it has massive implications. It breaks the dependency on the external advertising market. It also eliminates the need for external venture capital investors, who almost always push for rapid growth and, eventually, data monetization strategies.
So the control stays local, with the community and its members deciding what's valuable.
Precisely. The network's success is measured by its utility and health for its members, not by hitting ad revenue targets for shareholders. It allows networks to thrive, even at a scale that Web2 would consider completely unprofitable.
That philosophical goal, breaking up the dominance of the tech giants by empowering communities, it's definitely appealing. But I have to ask the critical question here. If decentralization and privacy are the main goals, how does Web4 avoid just building, well, different kinds of expensive, complex infrastructure? You're talking about moving heavy AI functions right out to the edge to people's devices or small community servers. What's the actual technology that makes that possible today, outside of, Google scale data centers?
And that is exactly where these microlanguage models, the MLMs, become absolutely crucial. They're not just a feature. They're the core technological engine making the whole Web4 decentralized vision technically and economically viable for smaller players.
Okay, so MLMs. We hear about the big ones, the LLMs like GPT-4, hundreds of billions of parameters. How small are we talking for a micromodel, and what are the trade-offs when you shrink them down that much?
It's a significant reduction. MLMs are essentially specialized small language models, or SLMs, that have been aggressively distilled, optimized down. While a big LLM might have 175 billion parameters, maybe more, MLMs are typically tuned way down, often under 1 billion parameters. The sources we look at specifically mention successful implementations down around 270 million parameters.
270 million? That's tiny compared to the giants. How do they achieve that?
Through intense specialization. They train these models for incredibly specific, narrow functions. They're not designed for general creative conversation like ChatGPT.
So what's the cost? What do you lose with that specialization? Does accuracy suffer?
You absolutely lose generality. An MLM isn't going to write you a novel or debug complex code across multiple programming languages. It can be quite brittle outside its very specific intended task. However, for that one narrow task, let's say, classifying the sentiment of a post or generating a relevant hashtag, its performance can often approach or sometimes even match a massive LLM. But the resource requirements, they plummet by factors of hundreds, even thousands. And that tiny footprint is what directly tackles the biggest weaknesses of those large centralized AI models. The privacy issues, the latency caused by sending data back and forth, and the sheer operational cost.
And because they're so small, parameter-wise, they become ideal for edge computing, running the AI right where the data is created, like on the user's phone or computer.
Exactly. That small size means these models can be packaged into highly efficient formats. You see things like .t flight files, which are optimized for TensorFlow Lite on mobile, or proprietary .tas files. They can run directly inside a web browser using technologies like WebAssembly or WebGL, or natively on a standard smartphone. This is huge because it completely eliminates that constant back and forth, that latency-inducing round trip to a distant server farm. The interaction feels instantaneous.
And for the user, the most immediate, probably most profound benefit is privacy by design. This is where the architecture itself enforces data protection, right?
Think about it practically. Let's say you're drafting a sensitive post. Maybe it's about a personal health issue or a confidential business idea. If an MLM is helping you, maybe suggesting hashtags or checking your grammar, that processing is happening locally on your device. Your raw, sensitive input never leaves the secure boundary of your phone or your browser tab. It's processed, the result is shown to you, and the input can be discarded locally, all without transmitting that sensitive payload across the internet to some third-party cloud server.
Wow, okay, that's a fundamental difference in trust right there.
It's arguably the highest level of data protection you can get for these kinds of routine functional AI interactions today.
So let's make this concrete. Can you give some specific examples of these MLMs? Show how these tiny tools actually provide real utility, not just theory.
Absolutely. Take the LSW4 270M microhashtags model mentioned in the sources. Its sole purpose, its entire reason for existing, is to generate relevant, semantically related hashtags based on the text to overuser types. Because it runs locally, the user gets instant suggestions. It reduces the friction of posting, boosts discoverability within the community network, and crucially, the system enhances visibility without needing to send your draft content off to some external AI that might also be profiling you for advertising. The goal is user utility, not platform surveillance.
Makes sense. And I imagine the same principle applies to content creation, which is always a bottleneck, especially for community managers or active contributors.
Yes, exactly. The LSW4 270M Micro T1 model is a prime example. Its specialization is creating short, engaging social media captions or post summaries. Again, it runs locally, accelerating content creation right there in the browser tab where you're working. The key takeaway from these examples is how Web4 leverages speed and privacy through this combination of hyper-specialization and aggressive model size reduction. It makes useful AI functions almost disposable, localized, rather than these monolithic, controlling, centralized intelligences.
Okay, but this raises a practical challenge for me. If all these little MLMs are running locally on potentially thousands of different user devices or within different community networks, how do you manage them? How do you update them or deploy new ones without some kind of centralized push, which seems counter to the whole philosophy? Sounds like it could become a maintenance nightmare for a small community operator.
That is precisely the problem that SNA's social networks as a service is engineered to solve. SNA's acts as that crucial infrastructure layer. It connects the local intelligence, the MLMs running on the edge, with the broader network governance and federation structure, making the whole thing manageable.
Okay, so SNES. You described it as a platform in a box concept earlier. What's actually in that box? What does a community get?
Essentially, it provides the whole pre-configured package, the infrastructure, the software. Often it's an open source distribution, maybe called something like Web4 Lite, and the goal is to dramatically lower the barrier to entry. Think about it. Launching a private, feature-rich social network used to require serious funding, a dedicated engineering team. SNES modularizes that entire stack. It gives communities the tools for secure hosting, templates for managing members, and crucially, a pre-integrated set of these AI agents and MLMs we're discussing. It makes owning and operating a network accessible to groups with a vision, not just tech corporations with deep pockets.
And that modularity, that ownership, it directly reinforces those core principles of control and sovereignty for the community operators, right? They're not just renting software from a vendor.
Absolutely not. The first major benefit is self-hosting and full control. The community admin, the people running that specific network instance, they maintain complete administrative control. Control over the platform itself, the underlying code, which, importantly, is often open source, so it can be audited to control over their own governance structure, and absolute control over all the member data. They aren't subject to some external company suddenly changing its terms of service or deciding to monetize their users' data in a new way. They own the digital space.
Which ties right back to monetization sovereignty. We establish Web4 avoids ads, leaning on membership fees. But I have to push on this point because this feels like where many decentralized or privacy-focused alternatives stumble against the free giants. Isn't the biggest hurdle simply that most users don't want to pay, say, $5 a month when they can use Facebook or X or whatever for free? How does News realistically overcome that fundamental market inertia?
That's a critical question, and it's probably the most common skepticism. Web4 platforms can't compete solely on price. They have to compete on value. It requires a shift in mindset from thinking like a consumer getting a free product to thinking like a member of a community investing in its infrastructure. The value proposition has several parts. One is control and ownership. Two is guaranteed privacy and data sovereignty. Three is often a safer, better moderated environment tailored to that community's norms. Four is escaping manipulative algorithms. Users are paying for stability, for the guarantee their data won't be exploited, and for an experience aligned with their interests, not an advertiser's.
So you're paying to avoid the hidden cost of Web 2, which is basically your own data and autonomy being the product.
That's a great way to put it. Precisely. And because these communities generate revenue directly from their members through these small, localized fees, they achieve genuine financial independence. They cut out the dependence on volatile advertising markets or venture capitalists demanding unsustainable growth. This means their definition of success stays focused purely on member satisfaction and the health of that specific community, not on hitting external quarterly profit targets.
And there's an efficiency angle too, presumably. If I'm running a community, not having to sweat the complex server maintenance and scaling, that must be a huge relief.
It's designed for exactly that. The SergeNAS system aims for maximum efficiency and scalability, with minimal hands-on maintenance needed from the operator. The core architecture integrates those AI agents, which we'll get into next, to handle many routine administrative and even scaling tasks autonomously. This drastically cuts down the labor costs and the technical expertise needed, letting the community operators focus their energy on what they usually care about most: the content, the member engagement, fostering the community itself, rather than worrying about infrastructure patches and server loads.
Okay, so we've got these tiny, powerful MLMs running locally, but how do you bridge the gap between that very specific individual task processing and the broader intelligence needed to actually manage a whole community? Keeping it healthy, active, moderated. This sounds like where the AI-powered agents come in. You mentioned them acting like persistent virtual managers.
That's right. The KI agent platform, as described in the sources, forms the network's operational intelligence layer. These agents are generally more sophisticated models than the tiny MLMs, still specialized, but focused on administrative functions. They act as autonomous community managers, moderators, even support staff. The idea is to ensure the environment is regulated, active, and, well, healthy, operating 24/7 without constant human oversight for routine tasks.
Let's start with maybe the most critical function for any online community. Automated moderation. We all know moderation on big Web2 platforms can be inconsistent, slow, often clumsy, culturally unaware.
Yeah.
How does the Web4 safety agent aim to do better?
It tackles this with a dedicated safety agent. This uses specialized transformer models. The source mentions one like LSW4 Aero Roberta R4 hate speech. Crucially, this model is often fine-tuned to detect toxic or hateful content based on the specific rules and norms defined by that community, not some generic global rulebook. And because it's integrated at the network level, running on the community's own sovereign infrastructure, it can monitor content submissions in real time, often before they even get published.
Okay, real time sounds good. What does it actually do when it detects something? Does it just delete the post automatically? That can also cause problems.
It acts based on the governance rules the community itself has set up. So the AI could instantly flag a post for review by a human moderator, transparently logging its action with a tag like automod flagged post, #8492. Or, if the content clearly breaches predefined red lines agreed upon by the community, it could remove it instantly. The key here is the transparency offered by the potentially open-source nature of the model. The community can examine, debate, and even adjust the parameters defining hate speech or toxicity within their specific context. This helps minimize the kind of biased or culturally tone-deaf moderation decisions that plague centralized platforms.
Right, adapting to the community's own standards. That makes sense. But agents aren't just about managing negativity, are they? They also help drive engagement, especially important for new or growing communities.
Absolutely. That falls to the content generation or engagement agent. These are tools designed to reduce friction and keep the community vibrant. For example, an agent might automatically draft welcome posts personalized to a new member's stated interests, pulling from profile info maybe. Or it could compile summaries of active discussions for a weekly newsletter. The system takes the initiative on these routine tasks, clearly marking its output like Content Gen drafted 3 new welcome posts. This frees up human admins to focus on higher-level strategy and relationship building instead of getting bogged down in repetitive tasks. It helps combat volunteer burnout.
And the third leg of that stool would be support, dealing with common user issues.
Exactly. The service agent provides scalable, instant support. These are usually specialized bots trained on the community's specific knowledge base, its FAQ, its rules, its tutorials. They can resolve common queries, password resets, how to use a feature, where to find information, often in seconds. And because these interactions are typically handled locally or within the secure community infrastructure, not routed through some massive external support system, it enhances user satisfaction and trust in the platform's responsiveness.
Okay, this brings us back to that core promise, on-premise data intelligence. You're talking about giving potentially small community operators serious analytical capabilities, like an enterprise might have, but without them needing to build or pay for huge data warehouses. How do they get insights into network health, user trends, things like that, without ever sending their raw member database to an external cloud provider for analysis? That seems like a critical piece of the security puzzle.
It is absolutely decisive for delivering on that promise of enterprise-level data sovereignty. The commitment from platforms like Web4 AI is explicit, 100% on-premise data security. The raw data, the actual database containing user information and activity, it never leaves the operator's secure infrastructure. That could be a physical server they manage or a secured private cloud instance they control, but the point is, the data stays put. The challenge then is how do you extract meaningful intelligence from that secure, locked-down data without compromising the security model itself?
Right. How do you do that technically?
The solution described uses a clever intermediary, natural language queries. They employ a specialized model, an agent like LSW4 Arrow T5 SDB agent. Think of this agent as a secure translator or an abstraction layer. Instead of needing a data scientist to write complex SQL code to query the database, a community manager can just ask a question in plain English. Something like, show me which discussion topic had the highest user retention rate last month, or what was the overall sentiment trend this week.
Okay, the agent translates that English question into a database query. But wait, doesn't the agent then need full access to the database structure to write that query? That sounds like it could still be a risk.
That's where the secure design comes in. The agent doesn't necessarily get raw, unfettered access to the entire database. It typically operates through a strictly defined authorized view layer or a secure API endpoint that limits what it can see and do. It translates a natural language request into a highly specific, often restrictive, secure query. This query is designed only to extract aggregated results, summary statistics, or predefined key metrics. It's intentionally blocked from exporting raw, personally identifiable user data. So the manager gets immediate, critical insights, things like granular user retention figures, overall sentiment trends, maybe rankings of power users, all delivered in real time without needing manual reports. And critically, this happens while upholding that guarantee. The raw data remains untouched, secure, and governed entirely by the local community operator. Now, all this sophisticated technology, the MLMs, these AI agents, the CUNI's infrastructure, it would immediately run into trust issues if it were all proprietary, locked away in a black box. That's why the commitment to an open source approach is so central to the Web4 philosophy. It inherently builds trust and transparency into the ecosystem, which is especially vital when you have AI involved in things like moderation and potentially even governance.
Yeah, that makes sense. By providing base models, maybe the core architecture, on platforms like Hugging Face or GitHub, they're basically inviting the world to look under the hood, to scrutinize it. This isn't just about being nice, it's a practical mechanism for ensuring the tools are robust, secure, and trustworthy, right? Especially when algorithms are influencing content visibility or user safety.
It allows for much faster, more secure iteration too. When external developers, security researchers, even academics can contribute to validating and improving these AI solutions, the transparency increases dramatically. The models inevitably become more resilient, biases get caught sooner, vulnerabilities get patched faster compared to systems developed entirely behind closed doors by a single company.
Okay, so open source builds trust. Let's talk about custom model development or fine-tuning. Because we know every online community is different, whether it's a group discussing, I don't know, high-frequency trading or knitting patterns or fan fiction. Each has its own unique language, its own culture, its own norms about what's acceptable. A generic one-size-fits-all AI moderator from Silicon Valley would likely fail miserably at understanding those nuances.
And the system anticipates that need for flexibility. It's built into the foundation. Communities are given the ability to fine-tune the provided base models. So they might take a foundational model, say like the LSW4 Arrow 2B model mentioned, which might be a general-purpose text model, and then train it further using their own localized and, importantly, anonymized community data.
Okay, walk me through that. What does that actually look like from the community manager's perspective? Are they uploading tons of data?
It's designed to be manageable. The manager might initiate a fine-tuning job through their admin panel. This process securely uses samples of community data, for example, posts that were flagged by users or moderators, maybe common support requests, all anonymized to essentially teach the base AI about the specific context. It learns the local jargon, what kind of arguments are considered constructive versus toxic within that specific group, what topics are relevant. Once the process is done, it might be logged clearly, something like fine-tune job FT toxic V2 completed. This signals that a new community-specific version of, say, the toxicity filter or the topic classifier is now active.
So the AI isn't imposing some rigid external rulebook written by lawyers in California, which often leads to nonsensical moderation or censoring harmless niche terms. It's actually learning and adapting to the community-specific culture.
Exactly. It shifts the AI from being just a blunt instrument of enforcement to becoming more of a flexible, culturally attuned system. The result is usually much more precise AI behavior, which leads to better user acceptance, fewer frustrating false positives, and ultimately less administrative work dealing with moderation appeals. And the variety of models mentioned in the sources really highlights how expandable this is. It's not just text. They talk about everything from text generation tools like LSW4 Slice 2B Consultant for maybe drafting documents, to complex classification systems, even experimental things like an object recognition model named LSW4 SX YOLO Lite V1 Candy. If a community identifies a need for a specific AI function, the architecture is designed to potentially host it securely and locally.
Okay, this is where it gets really interesting for me. Connecting all that technical underpinning the MLMs, the agents, the secure data to what the average user actually experiences day to day. Because ultimately, all these functions have to combine to create a genuinely better user experience, right? All built on that foundation of data sovereignty we keep coming back to.
Absolutely. The entire goal shifts. In Web 2, the user experience is often subtly, or not so subtly, manipulated to maximize engagement metrics that serve advertisers. Click more, scroll more, react more. In the Web 4 model, the design goal is purely about optimizing for efficient, useful, and healthy community interaction. It's about serving the user and the community first.
So let's tick through some examples. Immediate feedback, like sentiment analysis. You mentioned MLMs could analyze posts locally.
Right. Posts can be automatically analyzed for tone and sentiment as they're written or posted using those local MLMs. This can give instant feedback, maybe a subtle indicator to the poster, or aggregated insights to admins about the overall mood or tenor of conversations without needing to send the text off-site.
And that local processing drastically changes things like content recommendation, which is probably the most powerful and sometimes problematic algorithmic feature of Web 2.
It's a fundamental shift. Web 2 recommendation algorithms are notorious for pushing sensational, divisive, or addictive content because that maximizes time on site, which translates to ad views. In Web 4, any AI-driven suggestions for content or perhaps other users to connect with are based on local preference models. These models are derived from that secure, sovereign community data or even user-controlled preferences. The recommendations serve the user's stated or inferred interests within that community context, deliberately avoiding the influence of central, profit-driven algorithms. The network tries to recommend what's genuinely useful or relevant to you, not what maximizes the platform's revenue.
It also sounds like it streamlines the actual act of contributing, which can be a barrier for busy people in niche communities.
That's another key application of the on-device MLM's streamlining workflows. Things like automatic tagging and profile summarization. An AI can automatically suggest relevant tags for a user's post based on the content, like hashtag WFACE or hashtag productivity if it detects relevant terms, improving discoverability without the user having to manually brainstorm tags. It could also help summarize user profiles based on their contributions. In a federated network especially, discoverability can be a challenge. Automated intelligent tagging helps ensure valuable contributions don't just disappear into the void because someone forgot to add the right hashtag.
And this can even extend beyond just the online interactions.
Potentially, yes, event suggestions. Based on observed interests and activity within the secure community data, AI agents could suggest relevant community events. These might be virtual meetups, links to local chapter activities if they exist, or even just highlighting particularly active discussion threads aligned with a user's interests. Again, the goal is fostering genuine connection and strengthening community bonds driven by user interest, not by external commercial pressures, and all while respecting those strict privacy and data sovereignty mandates.
Okay, so pulling this section together. These features themselves, recommendations, tagging, sentiment analysis, they aren't necessarily brand new concepts. But by implementing them using local MLMs, running them on secure, sovereign community infrastructure, and divorcing them from external data harvesting, Web4 fundamentally transforms social networks. From systems often designed to extract value from users into what sound like self-sustaining AI-supported community ecosystems that actually prioritize user well-being, trust, and autonomy. Hashtag tag out.
So wrapping this all up, what does it really mean? We've kind of traced this whole architectural journey today. Web 4 represents fundamentally a deliberate shift of control, and that shift is enabled by its specific architecture. These microlanguage models, the MLMs, they're the tech that makes decentralization feasible, allowing for secure, powerful processing right at the network edge, often on your device. And then social networks as a service, SANUS, provides that robust, lower barrier infrastructure needed for communities to actually launch and manage these secure, independent platforms.
Right. It really seems to be that combination, the philosophical commitment to trustless systems, which is then enforced by verifiable code and open protocols, combined with the practical technical deployment of things like MLMs and on-premise agents. That's what seems to guarantee both the data safety and the operational efficiency needed today, ensuring that the community ultimately holds the reins, not some distant corporation.
But this does raise a fascinating and maybe challenging question for the future, especially thinking about the federated nature of Web4. We've explored how MLMs and on-premise data intelligence can safeguard data privacy and autonomy at the individual community level today. That seems quite robust. But what happens down the line when these individual community-run networks potentially scale up? When they start federating across regions, across national borders, and genuinely begin to challenge the global dominance of the established Web2 giants?
That's a big question, because when that scaling and federation happens, those local governance structures, the rules defined by users and admins in Town A versus Town B, those culturally specific moderation policies, the data usage agreements, they suddenly start having a much bigger impact, potentially influencing standards across the wider interconnected internet. The responsibility shifts dramatically away from a single, often opaque, corporate terms of service document towards these numerous local, hopefully auditable community contracts. So the provocative thought for you, our listeners, is how will you choose to participate in defining and enforcing the rules in a truly trustless system where your local community's governance genuinely matters and has ripple effects?
That really captures the profound opportunity and maybe the weight of building this next iteration of the internet. It's a responsibility that seems to land squarely on the communities themselves. Thank you for diving deep with us today.